All right, so we're going to talk about what opposite operations are. And one of the operations that we know is that if we have addition and subtraction, that these are opposite operations. And if I have multiplication and division, these are opposite operations. But what if I have something like something squared? What is the opposite operation of something squared? Well, that is a square root. And normally there isn't anything written inside here, but it really is a 2. And so the opposite operation of something squared is a square root. And they undo each other, just like addition undoes subtraction and multiplication undoes division. We're going to use this concept of a square root being the opposite operation of the power to simplify the square root of 16, the cubed root of 16, and the fourth root of 16. And what we're going to do this is we're going to start by factoring the 16. So I'm going to put this over here on the side and say I've got 16, and I want two numbers that multiply to 16. Well, 4 times 4, well, those multiply to 16. And I can continue to factor these and say, well, 4 is the same as 2 times 2. And this 4 is the same as 2 times 2. And I'm going to rewrite my 16 as a product of these factors. So when I rewrite this, I'm going to say, well, this is the square root of 2 times 2 times 2 times 2. And just like above, when I have a square root, we don't write it down, but it's assumed that this right here is an index of 2. So I'm going to sort of fix this a little bit because I didn't write that very well. An index of the square root of 2 is, or the square root of 16 is 2. So when I have an index of 2, what that tells me is I want to rewrite the product underneath the radical with powers of 2, because the index of 2 and the power of 2 are opposite operations. So I'm going to group these into 2's. And I can rewrite that as the square root of this right here is 2 squared. And that's an index of 2. And the square root of this guy right here could be written as 2 squared. And the index and the power, well, they cancel out. So I'm going to use this and say, well, these guys, they're going to cancel each other out. Just like this. And because they're sitting right beside each other and there's no operation between them, it's assumed to be multiplication. And I can write that as 2 times 2, which is 4. I'm going to do the same thing with the cubed root. I have the cubed root of 16, and I already factored 16, and 16 is going to be 2 times 2 times 2 times 2. And I need to group them with a power of 3 in order to get the index of 3 to cancel and be in the opposite operation of my power. So I'm going to group these 2's into a power of 3. But that just sort of leaves me with this remainder over here. So I'm going to have to deal with that too. When I rewrite this, I can say, well, this right here can be written as a power of 3, but it's still underneath that radical. And then I also have this 2 left over right here, and I have to write that underneath my radical. Well, I can cancel out my power of 3 and my index of 3 on this one, but I can't here because this is a power of 1. And it doesn't cancel out, so it just sort of is a remainder, and I'm going to write this down as the answer saying I've got 2 and the cubed root of 3. On the last one, I have the fourth root of 16, so I'm going to write that down just like I did before, because we've already factored 16, and say, well, that's the same as the fourth root of 2 times 2 times 2 times 2. And my index of 4 is telling me that I want something in a power of 4 so that they can be opposite operations and cancel out. I'm going to group these right here and say, well, I can rewrite that as a power of 4. So I'm going to say this is really the 4th root of 2 to the 4th. And because the index and the power are the same, they are opposite operations and they cancel each other out. And that leaves me with just a 2. So my index makes it so that my answers are different each time because the way that I had to get things to cancel was different each time.